Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. For today's show, we'll be taking a break from our Strata Data conference series coverage and presenting a special conversation recorded yesterday with Jeremy Howard, founder and researcher at Fast.ai, a company many of our listeners are quite familiar with due to their popular deep learning course. The podcast is being released today in conjunction with the company's announcement of version 1 of their Fast.ai library at the inaugural Pytorch Devcon in San Francisco. Jeremy and I cover a ton of ground in this conversation. Of course, we dive into the new version of the library and explore why it's important and what's changed. We also explore the unique way in which it was developed and what it means for the future of the Fast.ai courses. What's more, Jeremy shares a ton of great insights and lessons learned in this conversation, not to mention a bunch of really interesting sounding papers. I know you'll enjoy this one. All right, let's do it. All right, everyone, I am on the line with Jeremy Howard. Jeremy is founder and researcher with Fast.ai. Jeremy, welcome to This Week in Machine Learning and AI.
Thank you very much.
It is great to finally get you on the show. As you know, the TWiML community, in particular, our meetup has really been enjoying the Deep Learning for Coders course. We brought a group of folks through that course earlier this summer and spun up a second group to work on that course. And then you've recently announced the machine learning course, and we've got a group starting soon that will be working on that course together. So we are big fans of Fast.ai. The interview I did with Rachel, that was TWiML Talk 138 back in May, remains one of the most popular ones shows to date. So I am super excited.
Sam, the pleasure's all mine. And let me just say thank you so much for everything that you're doing for the machine learning and AI community. And thanks so much for spending time looking at our little course. I'm really grateful.
It is a great course, and we'll jump into all the reasons why, I am sure. But before we do that, I want to talk a little bit about your background. So you've been former president and chief scientist at Kaggle. You founded several startups in this space. You're a published researcher, as well as on the faculty at USF, and you're unabashedly PhD-less.
That's true. Unlike Rachel, who is bashedly PhD'd or something.
Yeah. So, I want to start out by talking about, I want to give you a chance to more fully kind of walk folks through your background, but also, maybe end up at the PhD, I think, has come to, this is a space where the PhD carries a lot of weight. And I'm curious your thoughts on kind of navigating this space and doing all that you've done without one, and what it says to, other folks that want to participate in the space.
Yeah, I mean, I understand where the question's coming from, Sam, because it's definitely always been intimidating and terrifying for me doing what I'm doing without an academic background. And I can't begin to tell you how deeply surprised I was when I discovered I was actually pretty good at machine learning, because I had no idea. Like, you have to realize, so to answer your question, I started my career when I was 18 at a corporate strategy company called McKinsey & Company. I got a degree in a Bachelor of Arts in philosophy, but I didn't turn up to any lectures because I was working full time. So I just turned up to exams. So I really, even though in theory I have a degree, I haven't really studied anything much in a formal way. So I'm kind of very unfamiliar with the university system and the academic system overall. And so I spent, 8 years in corporate strategy and then 10 years running a couple of companies, which were somewhat related to machine learning, but one of them was an email provider called Fastmail, which is still pretty popular. And the machine learning I did there was like, try to improve the spam detector mainly. And then the other one was an insurance pricing company called Optimal Decisions, which was more about operations research and optimization and simulation than it was about predictive modeling. So at the end of all that, when I entered my first Kaggle competition, because I wanted to finally learn to do machine learning properly, and I won it, I was just like, that can't be right, because I knew that it was an econometrics competition, and there was a lot of PhDs and professors in econometrics in the competition, and I just thought, that's really weird that some kind of self-taught hack, business guy could possibly beat these guys at predicting time series. I just thought that was, deeply weird and surprising and very pleasing. I mean, it was the start of a new career for me, because when you find out you're good at something, you kind of, at least in my case, I went all in on trying to be as good at it as I could be.
I didn't realize that your career at Kaggle began with competing in a competition.
Yeah, so at that point, it was just Anthony Goldblum, and he had, hired a contractor to kind of hack together a site based on his idea of creating a competition platform. And yeah, I came across it because I went to the R meetup in Melbourne, thinking that would be a good way to learn to do machine learning properly. And somebody there told me, oh, a good way to learn machine learning would be to try one of these Kaggle competitions. And so I did. Much to my surprise, I won my first one, and I think I also won my second one, and I got to the top of the leaderboard. And so by the time the next meetup came along, Anthony was actually at the meetup, and somebody introduced me, and by that stage he knew who I was, because I was the highest ranked Kaggler. And I ended up becoming the first investor in the company, and then I rewrote the whole platform from scratch as a volunteer, because it turned out it wasn't really going to be scalable enough to do what was needed to be done. And I ended up becoming an equal partner in the company. So that was a cool way to get involved.
Oh, that's pretty amazing. And people often kind of poo-poo Kaggle competitions, and
they do,
with comments like, it's not really the real world. All the hard stuff is done for you. I imagine you have a slightly different.
These are not people who compete in Kaggle competitions, though. These are people who have heard third hand, and it's
What's your take on that? A lot of the exercises in the Deep Learning for Coders course are, hey, just go find a data set on Kaggle and do some stuff with it. So you obviously believe pretty strongly in that as a way to learn.
Yeah, I do. That's a great question, actually, because, like with many of these troubling myths, there's just enough of an element of truth in it to make it sound believable, which is like, obviously, there is a lot to building a data product or solving a data-oriented problem that is not about creating a more predictive model. So, yes, that's true. But then, taking that premise that therefore competing in Kaggle competitions is a waste of time is a totally ridiculous leap. Because actually, if you want to do a good job of your data product, having a predictive model that's good at predicting things is actually a pretty important part of that. Furthermore, Bryman, who developed the random forest, amongst other things, had this fantastic Two Cultures of Statistics paper in which he talked about how incredibly powerful a good predictive model is as providing a platform for data interpretation, for understanding your data. And that's one of the things that I spend a lot of time on the new machine learning course. So if you're going to kick ass on a Kaggle competition, you need to understand the data really, really well. And so if you're good at understanding data really, really well and building models that are very predictive, And you also have to be really good at software engineering in a very practical way, because every idea you come up with, you have to be able to code it in a way that actually works correctly, that's tested. And then you need to make sure it's maintainable, because you're going to, patch lots and things on top of each other over the 3 months of the competition. So realistically, if you can get a good result on a Kaggle competition, you have exercised many of the pieces necessary for machine learning in the real world. The other pieces like productionizing that model, that's a whole different skill which you can practice elsewhere, or skills like figuring out what problem to solve, and what constraints there are to solve that problem. I mean, that's kind of more of a management consulting, corporate strategy kind of issue, which, again, there are resources for that. But yeah, for the part that is really about machine learning, Kaggle competitions are a great exercise.
You made an interesting comment in there that winning a Kaggle competition and building models in general is very much about really understanding the data. And in the Deep Learning for Coders Part 1 course, you kind of, my personal experience, we kind of sailed through the first 3 lessons that were focused on building object detectors and things like that. And then we got to this really interesting set of lessons around using machine learning for more tabular data. Mm-hmm. And the promise of that is that actually kind of the opposite of what you said, that, previously, in order to really work with, traditional enterprisey data, a data scientist really had to be a domain expert and understand those domains and the data sources very deeply. The impression a lot of us took from, what we learned in applying deep learning to tabular data is that, we didn't have to be as deeply ingrained in that particular field, because the network would learn a lot of the patterns for us.
That's definitely
how do you
true.
Reconcile those two perspectives?
Well, the first thing to note is there's a difference between getting a pretty good model and winning a Kaggle competition. And so winning a Kaggle competition, you actually have to do everything better than everybody else, because if you don't, somebody else will do that thing better than you and will beat you. So, Kaggle, it's definitely true that Kaggle solutions, like the top 10 Kaggle solutions, are going to be very over-engineered for practical purposes. But what they show you is kind of the full menu of things which can improve your model, and you can kind of pull each one out one at a time to figure out how important each piece is. So doing some amount of feature engineering is almost always helpful, and doing a lot is going to be necessary to actually winning a competition. Having said that, it's definitely true that deep learning allows us to do less feature engineering and still get as good results as we might have with GBM or a random forest or something. And there's been some interesting papers and talks from folks like Instacart and Pinterest who have switched from GBM-based methods in their companies. So Pinterest switched from GBM to deep learning, for example, for their homepage, kind of main homepage recommendation feed. And they've talked about how doing that made their engineering process less complex, because they didn't need to do as much feature engineering as they did before. The architecture kind of did more of it for them. So you generally, with deep learning, you don't have to bucketize your continuous variables, which some kinds of model require. You don't have to create interactions, which some kinds of model require. You don't have to do special tricks to allow it to extrapolate further, which you certainly need for any tree-based method. So yeah, I think both of those things are true at the same time.
Mm. Yeah, certainly the course in our group created a number of fans of the whole technique of entity embeddings. It was really eye-opening.
Yeah, very underappreciated. I mean, the idea that you can use a mixture of categorical and continuous variables kind of without thinking about it is great, and you can use them for time series, you can use them for tabular, you can use them for collaborative filtering, you can use them for text. I mean, they pop up everywhere, and actually, I'll be interested to see your feedback when you try it. But the new Fast.ai version 1 library makes that like ridiculously easy. Like now you can basically create a model with a mixture of categorical and continuous variables in, and train it in 3 or 4 lines of code. Because we're really trying to, make that idea of entity embeddings be as natural to use as possible.
Well, I appreciate you helping us get to talking about the new library, which you're going to be announcing tomorrow. Today, for those who listen to the podcast, the day it's released, because we're going to try and get this out tomorrow. Let's talk about the library. So Fast.ai as a company is focused on, research, it's focused on software, it's focused on courses. We talked a little bit about all of that with Rachel. This is really about the software.
Yeah, and this is the long-term vision of what Fast.ai is doing. And I'm a bit sloppy about this myself, but our company is Fast.ai and the software is just Fast.ai. So Fast.ai, is all about getting to a point where people can use deep learning to help them do whatever it is they're doing really easily. And to allow anybody to do that, we actually have to get to a point where you don't have to use code at all, because only something like 0.1% of the global population knows how to code. So kind of the Fast.ai library is step 1 along that path to kind of require less and less code to be able to do more and more things more and more reliably, more and more quickly.
Since you grounded us out on terminology, another area that's somewhat confusing is that you're announcing what you call the V1 version 1 of the Fast.ai library, but it supersedes a previous version of the library that was also written in Pytorch, which itself supersedes a previous version of the library that was written in TensorFlow.
Yeah.
So when we talk about the V1 library, we're talking about the new thing.
So just to go back through that. So the previous thing was version 0.7.
Okay.
And that never got a version 1 tag because I wrote it knowing that it was not going to be that particularly close to the final form of what we wanted. It was kind of something that I hacked together that was good enough for the needs of the initial Pytorch-based courses, because as you well know, Pytorch is really not suitable on its own as a first library for deep learning, because you have to write your own training loop and you have to do a lot of things yourself, and it's pretty it's an amazingly great library, but it's kind of missing that Keras style layer on top. So we kind of built the amount we needed to get people going, but we it was certainly not a really carefully integrated, fully thought through library. So here we are, 18 months later, we've rewritten the entire thing from scratch in a way which is explicitly designed to provide a long-term foundation for all the software we build from now on. And then before that was something that was, sat on top of Keras and TensorFlow, and I don't think we ever even called that a library or gave it a name. It was only a kind of bunch of little utilities that sat on top of Keras to smooth over some of the slightly rough edges. That's been kind of the progression. And so it's really the first time where we're saying, okay, you know what? This software is actually now, we think, pretty damn good. We're pretty damn proud of it. We think people should start using it for, basically anybody who's trying to train neural nets. We think this is the best software out there for doing that.
And specifically for kind of production use as opposed to education or rapid prototyping?
Yeah, and I know there are certainly Fortune 500 companies using Fast.ai 0.7, but they're nearly entirely Fortune 500 companies where they have a lot of their technical staff who have done the courses and got introduced to it that way and are kind of happy to dig into the source code as necessary to make it work the way they want it to. So yeah, now this is, we think this is totally ready for everybody to use. It's also like a good time for it because it's aligned with the Pytorch version 1 release. We're a little bit ahead of them, so we're actually using the Pytorch version 1 pre-release now, and when the final release comes out, we'll be obviously supporting that. But Pytorch version 1 has done a lot of work on the productionization story with the integration of Cafe 2 and the kind of full support of ONNX and stuff like that. So because any Fast.ai model is also a Pytorch model, you can use all of that new functionality to serve your Fast.ai models directly.
You made an interesting post about the methodology behind developing the new library that was actually somewhat controversial on the TWiML Slack. If I remember the gist of it, it was that the library was built from the ground up relative to 0.7 and specifically built kind of using or around the Jupyter notebooks that will eventually become part of the course or maybe the part 2 version of the course. Talk a little bit about that process.
Yeah. Okay. So this is actually pretty fascinating. I'm glad you brought it up because it's not something I've had a chance to write about yet. So this will be the first kind of proper description of this. Here's what happened. The first thing is I just love working in Jupyter notebooks. I've been coding for, well over 30 years. But I just, in many different languages, but I just write better code faster when I'm in a notebook. And so I like that, but it's, writing stuff in a notebook is not something that's really been well suited to creating, reusable modules in the past. So kind of that was issue number 1. Issue number 2 is that we've got this kind of unique thing we do when there's an in-person course on, where I make a big room available every day during the course, and I tell everybody, all the students, I'm going to be working in this room. If anybody else wants to work with me, you are most welcome to do so. And so during the course, we have a whole bunch of Fast.ai students, hanging out, working together, and generally I've got my work being projected onto a big screen so people can kind of watch. And one of the most common things I hear from the students is, gosh, I learned so much watching you test and refactor and build, which I don't get out of the course. Like in the course, everything kind of just appears all done. And I think one of the things people surprise me is how much I screw things up. I'm just constantly making mistakes and fixing them. And, everything is a lot harder than people perhaps realize based on what they see in the course. So the question I often get is like, how can we learn to kind of develop software, machine learning software the way you're developing it? So what I did was I decided the next version of the software, version 1 of Fast.ai, which we're releasing today, I am going to build in notebooks where each stage I'm going to leave all the cells in there so you can see every stage of that progression. So you can see what I built first and then how I refactored it and then what I checked it against and so forth. So as a result, there's this series of, something like 14 or 15 notebooks, which if you go through the whole thing, you end up writing the entire Fast.ai library yourself.
Wow. And so that
14 notebooks.
14 notebooks, and that'll eventually be the part 2 course, which the current part 2 course is kind of taking you into the internals of the old library. So this is a new approach to doing that for the new library.
Yeah, and in the process, you're going to have to learn about a lot of recent research results because, as you're aware, even the 0.7 and particularly 1.0 integrates a lot of recent research results to kind of make them directly available. So as you go through part 2, you're going to be like learning about, what paper is this particular line of code based on and why is it done that way and so forth. So yeah, you'll both learn a lot about modern kind of cutting edge deep learning research, but also about the process of building machine learning software. And so what we did, it's like really simple, but it worked really well, is from time to time as I was kind of building a notebook, I can create a function that I'd kind of think, okay, that's probably going to be useful to use again. So I just put a little comment at the top, and my comment was always hash export. And anytime I had a little thing running in the background that anytime it saw a cell that said hash export, it would chuck it into a Python module. And so I could then build the next notebook on top of the previous notebook by simply importing the previous notebook's auto-generated module. Huh. And so then at the end of all that, we then went through a manual process of kind of figuring out like, okay, well, what have we ended up with here? And we kind of structured things into a carefully decoupled set of independent modules, which ended up being Fast.ai, and wrote all the documentation and so on and so forth. But, it really, you can really see the final result is close to identical to what you'll see in those notebooks.
One of the issues that was raised, and I think I raised questions along this line. Well, I'm sure I raised questions along this line as well in our Slack is, that sounds like a very kind of organic way of coming up with the library that may not lend itself well to kind of the durability and, well-architected APIs that you would want if you're going to be using this for a general purpose. Like, how do you...
That's a great question. So that's how I used to think too. And about 20 years ago, maybe a bit less, I got super interested in test-driven development. And for those that aren't familiar with it, the kind of basic idea of test-driven development is you kind of write a bunch of tests, you make each one pass one at a time. Every time you find you've got some duplicate code, you refactor it into a class or a function. You try to figure out what it is that class or function's doing based on that duplicate code and give it a name. And you keep on repeating this again and again and again. And I kind of just played around with it because a few people I respected thought it was great. I thought it sounded really weird. And one of my key issues was what you just said, which is, well, what point do you actually design a durable, thoughtful API? Much to my surprise, I discovered that this process of testing and refactoring naturally ended up just through having to refactor out these abstractions and then abstractions on top of those and then abstractions on top of those and carefully naming things. I ended up with better APIs than I'd ever written when I'd carefully designed them. And, I should mention I've spent a lot of time designing APIs. I wrote a number of MVC modules. I was the Perl 6 chair for all the data functionality in Perl 6. So I explicitly was writing RFCs for that API. I've written a lot of APIs in my time, and I've discovered that this organic approach, I end up with better APIs. I end up with no stuff in them which actually doesn't need to be there. So unnecessary complexity is entirely avoided because you only build what you need. I end up with less kind of unnecessary and overcomplex abstractions. So I kind of end up with something that's concise and neat. And I don't know, like when you try it out, see what you think. I am really, really proud of this API. Like I found that we have almost identical 4 lines of code to build a NLP model versus a computer vision model versus a tabular model versus a collaborative filtering model. I found it a real pleasure to work in, frankly.
Definitely looking forward to that. Yeah, since you mentioned your work with Perl, I will admit that in working with the 0.7 version of the API, at some point I grumbled in our Slack channel that, some of the the attribute and function names seemed unnecessarily terse. And, Jeremy must have been a Perl developer in a former life. And someone said, oh, yeah, he was actually a Perl committer.
Yeah. And I mean, I think it's fair to say also that some of them were unnecessarily terse. So we've actually changed from a rule of thumb of symbol parts should try to be 3 letters or less to kind of symbol parts should try to be 5 letters or less. And that's actually made a big difference to be able to say train rather than TRN and valid rather than VAL. It's actually worse than that, though. I'm not just a keen Perl programmer. I'm also a keen kind of J and APL programmer, where everything is one symbol.
So we should expect like deltas and upside down deltas and Greek letters
Yeah,
creeping in.
so not quite, right? Because I mean, I could talk about this for hours, but I'm just fascinated in notation, and my kind of hero here is Kenneth Iverson, the Turing Award winner, who wrote the classic Turing Award lecture, Notation as a Tool for Thought. And in it, he describes how good notation helps you, do good work, do good research, come up with new ideas, implement things more quickly and easily. And good notation, as he defines it, is very, very different to what kind of PEP8 Python looks like. Good notation is something where your kind of eye can quickly look at one part of the screen and capture the gist of what's going on. So it's about using vertical space really carefully. It's about kind of having common idioms be easily recognizable. And so I would say to get to that point where you've got notation as a tool for thought, you kind of have to slightly give up on Python's goal of being immensely friendly even to the most new programmers, and say, okay, no, I actually want people to invest a little bit of time learning this, but the promise will be that if you do so, you will be immensely more productive as a result. So, we definitely don't go anywhere near to the APL and J level of that kind of premise. But nonetheless, it is the premise.
I don't know of J, but APL was a language that I studied for a few weeks in my first computer languages survey class at school.
Great.
And I remember those weird keyboards very well.
So J is kind of an ASCII version of that, largely written by Kenneth Iverson's son, actually, because Kenneth Iverson wrote the original APL. But you've got to realize, APL goes back to, it was originally written as a mathematical notation, not as a programming language. And so, that came out in the late 50s. The implementations came out in the early 60s. Still today, many big and successful companies choose to use APL for their most important stuff, particularly, big hedge funds. So the fact that this is a notation that has survived many, many decades, longer than any other widely in use language today, I think it tells you a lot about how extraordinarily it was designed. And it's something everybody should study it at some point, because it's, you learn so much from seeing this totally independent language evolution path.
I did not realize it was still in wide use.
Oh yeah, absolutely.
So, maybe to digress a little bit from the library, you've already mentioned a few papers, and one of the hallmarks of the library is, that you have identified these, in some cases, relatively obscure papers that have outsized results in terms of training efficiency.
I love doing that. Yeah.
And clearly you do. The question, and maybe why it's a digression, is, how do you keep up with all of the stuff that's happening in the space? And, to the extent that you're able to drop in these obscure references in both code and conversation.
Twitter, basically. The Twitter machine learning community is really terrific, and you can quickly become a part of it if you go to my Twitter page. So I am Jeremy P. Howard. If you go to my profile, you can click on my likes, and you can immediately see, who am I liking things from, and you'll see that there's just a long list of people posting about mainly about deep learning. So you can start following the people you find interesting. And it's just a really rich, highly technical community. I'd say the other thing I do is I explicitly look out for the stuff that other people are missing. So rather than kind of trying to say, oh, here's a really popular paper everybody's talking about, instead I kind of look out for oh, here's a extremely good model somebody's built, but nobody's talking about this paper, because that's where I get to do something that other people aren't doing. So I get to kind of contribute more. And so I'm particularly interested in looking at, I always read the winning blog posts from Kaggle competitions. I look at if you go to any machine learning or deep learning workshop website, you'll generally find posted papers from the people that won that competition. They are an astonishing source of tricks, but those things never generally get published anywhere else. So, and they're never they don't appear in search results. So you have to go and find them. But in like these workshops where people say, here's how I won, this academic competition's object detection path, they'll generally say, these are all the other papers we looked at. These are the things we tried. These are the things we worked. These are the things that didn't work. So that's a really great trick.
Oh, that's an interesting hack to focus your efforts on papers where there's a competition involved somewhere.
Yeah, focus on stuff that works. And, even that's much more controversial than it should be, because there's this kind of view in the academic community that researchers don't really need to worry about, the latest and greatest tweaks, and techniques. But the truth is, people building deep learning models are doing it because they're trying to make something that's more accurate than somebody else's model or trains faster than somebody else's model. We're not just doing it because of the mathematical purity of it or something. So, and furthermore, if you're claiming that your model, your architecture, your training method, your optimizer is better than some other thing, you have to compare it to that other thing. And if you don't know how to actually train a good modern model, then your experiments are pretty much meaningless anyway. So, I think it's really important for practitioners to be familiar with, in practice, how are people actually training these most accurate and fastest models.
Mm-hmm. At the recent Deep Learning Indaba event in South Africa, Jeff Dean made a comment about how, one of his secrets to success, if you will, is as opposed to going deep on fewer papers, going shallower on many more papers, he thinks is a preferred approach. Do you ascribe to something similar, or do you have other kind of, hacks for learning and keeping up?
I think that's basically right. I mean, like when you think about it, if you don't use that approach, then, think of like, your knowledge is a weighted average of the kind of the inputs you're putting into it, right? And so anything that you don't read or look at gets a weight of 0. So you can't it's kind of easy to pretend like, oh, I didn't look at it, so it doesn't count. But no, you've chosen to put 98% there and 2% there and 0% on these other 1,000 things. So yeah, I think it's definitely worth going broad. But I'd also say I look out for the themes. And so for me, one of the most important theme at the moment is transfer learning beats everything all the time. And almost nobody's really doing, not totally nobody, but almost nobody's actually doing research about transfer learning. Most papers don't actually apply their techniques to transfer learning. So, for me, here's a theme, right? So every time I see anything that I think, oh, that, what if you added transfer learning to that? Or, what if I use that transfer learning technique in this different field that doesn't currently use transfer learning? So like our ULM fit model, which is the state of the art for text classification, pretty much everywhere it's been looked at, now in multiple languages. That was just me saying, how come people never use transfer learning properly in NLP? I should try it. And it's kind of like following that theme.
And I won't go deeper on that because I do have a conversation with Sebastian scheduled to dig into that sometime soon.
Oh, good.
Maybe back to the library and the course. I've heard some, I don't know if they're rumors, something that you wrote gave folks the impression that the new Part 1 course is kind of turning away from this top-down approach and taking more of a bottom-up approach. Is that true? And before you answer that, I will say that, so we did these weekly study group sessions, kind of like virtual sessions where we all got online and talked about, what we were learning in the course. And we spent a ton of time almost every week talking about top down and just getting used to it. It's very different from the way folks learn, but very effective at kind of getting you pulled in quickly.
Yeah, I mean, it depends a lot on your background, right? I mean, in a lot of kind of more MBA style stuff, it is often a lot more top down. A lot of kind of executive education is a lot more top down. But most people who are kind of coding have come from more of a computer science academic background, which is very bottom up. No, we're not stepping away from the top down approach at all, because it's all of the educational research I've studied, which is a lot, shows that by far the majority of people learn better with the top down approach, even though it requires to some extent unlearning how to learn based on the bottom up approach that we kind of get used to from school and university. I will say the machine learning course, the Introduction to Machine Learning course, is it's still pretty top down. Like lesson 1, the first cell is, here's a random forest, we've trained it, and here's the result. And then we kind of gradually dig into like, how do we interpret that result, and how do we actually build that tree? And by kind of lesson 7, we write our own random forest from scratch in pure Python. But I don't know. Yeah, I think because the people I was originally doing that course for were master's students, I possibly was a little more, I don't know, go a little bit deeper, a little bit earlier, so that they didn't get too uncomfortable with the kind of change of style.
I'm looking for the details here, since you mentioned that machine learning course. The course has been kind of, it's been around in a pre-release state, I guess, for quite some time. Right. But since it's been formally released, we've got a study group that some folks in the community are organizing that will be starting very soon. In fact, lesson 1 is going to be on Sunday, October 7th at 3 o'clock GMT. And they're going to continue that for, 12 weeks on Sundays at that time.
Great. Well, let me encourage people to get into that, even for folks who haven't done the deep learning course yet. Like, you can do the two in either order. They both are designed to work well together. But it's definitely true that people who study with a group on average have more effective learning outcomes, and more importantly, tend to stick with it for longer than people who study independently. I think that sounds like a fantastic initiative, and I hope people listening join in.
Yeah, well, we had a great group that did the deep learning part 1 course together this summer. And in fact, most of the, this course and we've got another session of the deep learning course that's going now. I'll elaborate on that in a second. But these are all kind of being run by folks that came together to do this deep learning course together. So it's been awesome for us.
Yeah.
On that deep learning course, so we had a group that started three weeks ago. I think they've had 3 sessions. A second group on the Deep Learning for Coders Part 1 course. We made some tweaks to how we did it. The first time we did it, we were planning for a weekly pace. We held that through about the 4th lesson, and then we went to biweekly because it gets a lot harder.
Yeah.
And so this time they started doing a biweekly pace all the way through. But one of the things that threw a little bit of a wrench in our plan, a good wrench, is that you announced that for the new course, which is going to be starting towards the end of October, although we noted that the notebooks haven't been written yet.
No. Yeah, I should probably do that.
But for this new course, previously the options for taking this course were you could take it in person and you offered a bunch of different types of scholarships, or apply to take it remotely during kind of the live course time, or wait a few months and catch it via video. But you just announced with some pretty interesting kind of background commentary that you've decided to make the remote course available to anyone who wants to sign up for it.
Yeah, as long as, the only thing I ask is that you follow along live, which means if you're in a annoying time zone for our evening US time classes, that you get up and do it anyway, because I want people involved to be contributing to the real-time, chat during the course. But other than that request, it's open to anybody who has at least a year of coding experience, and definitely looking forward to seeing how this little experiment works out. I think it's going to be really cool.
Yeah, that was one of the questions that folks had, was whether for folks that are in kind of off time zones, whether the videos would be made available any sooner so that they could, participate via forums and groups like ours, but watch the videos at a slightly more convenient time.
I can't technically stop anybody from doing that, I guess, because it's on YouTube Live and the videos appear on YouTube Live. But I would certainly much prefer people to actually be there during the class, because that's where we're having the discussion. You can ask me questions, while the lesson's going on. I think that's what makes it a really rich and interesting experience.
We started this course, a second session of the part one course. You threw this really a great wrench in our plan. And so what we've decided to do is we'll kind of continue for the part one course, the first couple of lessons. But as soon as that, the new course starts, which I think you said was the 22nd of October, if that date holds, we will be kind of switching gears and working on the new course, the new library, et cetera. And everyone's really excited about that.
And people do need to sign up to participate in Fast.ai Live, so I'm sure you can provide the link there that they can do that with.
That's right. So we'll include that in the show notes, and then the sign up for the meetup and for our study groups, that'll be at TWiMLAI.com/meetup. So maybe kind of jumping back to the library, one of the things that you are kind of including in your announcement about the new library is some benchmarking that you did relative to the Keras library. Can you talk a little bit about that and what you showed?
Yeah. So, I'd love for people to help do more benchmarking. I only had time to quickly throw something together. And I will say it's been a while since I really used Keras, so I tried to find documentation on best practices, but there actually is, I couldn't find anything post 2016 in terms of official, here's how to do transfer learning in Keras. So it's possible that my Keras approach is not as optimal as it could be. But basically, I tried to use the classic Kaggle dogs versus cats dataset to transfer learn a ResNet 34 and just tracked how many lines of code it took. And I tried to optimize my Keras lines of code as best as I could, how long it took to train and what accuracy I could get. I was very pleased to find that the Fast.ai library code was something like a fifth as many lines and was quite a bit faster and quite a bit more accurate, which is, it's really all about the little, all the stuff we curate, both in terms of papers that we incorporate into the defaults and also some unpublished research, which we hope to publish later this year around ways to do this kind of training better.
One of the things that I did notice about the new library is the code to do fine-tuning got very compact relative to the 0.7. Can you maybe talk a little bit about that and more broadly, like the differences that folks should expect to see when they start working with the new library?
So Perl, since we've talked about Perl, has Larry Wall, who wrote it, has this motto, which is make the easy things easy and make the hard things possible. And so to me, it's not just about making the easy things easy, but make the important things easy. And there's nothing more important than transfer learning. So we tried very, very hard to make it basically transfer learning is kind of the thing you get automatically and for free. So if you create a model, by default, you'll get some pre-trained weights, and by default, you'll get something that is set up for discriminative fine-tuning and set up for, layer freezing and, all the stuff you need that you'll know from the course if you've done it. Yeah, but then, the nice thing is that all of the power of Pytorch, we very intentionally make as close to the surface as possible. So, for example, we integrate very closely with Pytorch, and we use a lot of Pytorch APIs directly. So, for example, a Fast.ai dataset is a Pytorch dataset. The Fast.ai data loader is a wrapper for the Pytorch data loader. And in our docs, which actually we should talk about our docs a bit because it's one of the things I'm most proud of, but in our docs, everywhere that we are using a Pytorch object, you'll see that there is actually a hyperlink directly to the Pytorch documentation for that class or function. So, the two libraries are really nicely integrated.
Oh, that's awesome. I'd love to hear you talk a little bit about the docs. With the 0.7 library, for the most part, the code was the docs.
Yeah, there was no docs.
And in fact, someone from the TWiML community, Kai, contributed some docs and was told, well, hold off on this because we're going to do better. So what have you done with the version 1 library?
Well, you won't be shocked to hear this, but the entire set of documentation is written as Jupyter notebooks.
Oh, nice.
And so that means that every page in the documentation, you can actually run it in your own, Jupyter notebook and see the experiments. So that all of the documentation is designed to be a very, every module starts with an overview of like, hey, here's some code you can run right now to, build this kind of model or to do this kind of data augmentation. We wrote our entire kind of computer vision library from scratch in Pytorch, full new set of transformations. Every transformation, therefore, is documented as, a line of code in the docs that actually, prints out examples of that data augmentation, shows you the pictures. So then what we've written is we've written a whole new documentation framework, which takes those docs and turns them into a website. And that website, for example, it does things like any place you've used backticks to kind of say, hey, this is code, this is a symbol. It will automatically try and find anything in that code that represents a Pytorch or Fast.ai class or function or object. It will automatically generate a hyperlink to that. So you can basically write, standard markdown cells. You can standard code cells, inputs, outputs, pictures, everything will then automatically generate this fully hyperlinked table of contents, searchable documentation with embedded pictures and all that kind of thing. And then, you can go and try it out yourself by actually loading up that notebook locally and trying it out. So I think it's, as far as I know, it's the first time anything like this has been done, and I think it's going to be super helpful for this kind of thing we say to people, which is, hey, you should be experimenting, you should be running code, you should be trying things out. So now all of the documentation, is stuff that you can try out as experiments.
Oh, that sounds tremendous. I'm not aware of any. I've never seen code distributed as Jupyter notebooks. That does sound very cool. Someone mentioned that you tweeted something about some extensions to Jupyter that you were creating.
Yep.
Is that what that's referring to?
Yeah, they're not actually extensions. It's a framework of. It's a bit like Sphinx, if you've ever used Sphinx. It's kind of Sphinx on steroids, but for notebooks. So basically something where you feed in Jupyter notebooks and it spits out a nice documentation website for you.
One of the things that comes up occasionally is folks that want to develop in Jupyter notebooks and then productize, productionalize that code. Are you using techniques in this process that could be also used to take a Jupyter notebook and maybe identify parts that are annotated as being the kind of the export thing that you're referring to, and then put those into a production module?
Yep, absolutely. So, as we go through part 2, which I guess will be kind of first and second quarters of 2019, that's kind of what we'll be doing, is we'll be seeing how to go through that process. For me, I like automating things the right amount, which is like not too much and not too little. So for me, this kind of exporting cells is a great way to kind of gradually build up much of the API that you want. But then the piece where it's like, okay, let's create a really nicely designed, decoupled set of modules with clear dependency paths and all that kind of stuff. That's something I did. Well, actually, Sylvain and I did together, manually and carefully. So I'm not really into kind of necessarily directly turning a Jupyter notebook into a module, but we certainly got use some simple tools to help us semi-automate that process.
Okay. What are some other highlights that folks that are familiar with the 0.7 library should expect to see or should be on a lookout for with version 1? Yeah,
so this new data augmentation / computer vision library is something which you should definitely check out because it's actually something which the Pytorch team helped make sure that Pytorch was explicitly performance accelerated for exactly the things we needed for it. So it's very fast, and it actually ends up with much higher quality outputs than any existing data augmentation library. Because normally if you do like a rotate and then a zoom, for example, it basically interpolates on top of interpolation, and you end up with these kind of fuzzier and fuzzier images. Whereas we use an approach which actually keeps all of the sharpness of the image throughout the process. We also have this allows us to actually incorporate as default some kinds of transformation which pretty much nobody else is using, particularly perspective warping, which is a really important transformation in practice, but it really requires this special kind of library to make it work effectively. So I'd say definitely check out the computer vision transformation library we've built. I'd also say have a look at the really good support for NLP transfer learning. Quite a few of the community on the Fast.ai forums have been trying out the ULM fit technique, so basically transfer learning for NLP in non-English languages. And in the last week or two, I've heard from 2 Polish students that they just won the main Polish academic competition. Somebody else has just got the state of the art for German. And then a few months ago, somebody got the state of the art for Thai. And like in the German example, the chap on the forum basically said, hey, I tried it. I trained it for 20 minutes. The first thing that popped out was the immediate state of the art for German. So, for NLP, you can basically incredible. Do stuff with this library you will get better results than anybody's published before, kind of trivially. And we actually include, if you look in the examples directory of the repo, just click on the text example. That'll actually show you how to do it end to end. There's certainly, the very much easier support for tabular data sets that's there is definitely worth checking out. It's not that it's doing anything that you couldn't do with 0.7, but it's now super, super easy. Yeah, and I think also just check out the documentation framework, because we do plan to extract that out into a separate independent project at some time soonish. I'd love to see more people trying to build Jupyter-based documentation systems, because I think it's really helpful, to your users to be able to say, hey, all of the documentation is code that you can run yourself right now and try it out.
So the current library is very much focused on supervised learning, and as we've discussed, transfer learning. Do you see the library moving into models like reinforcement learning or unsupervised learning?
Reinforcement learning, no, at least not in the short to medium term. I'm still unconvinced that we really know what we're doing as a community when it comes to reinforcement learning. The good results we're seeing are largely because of, hacks that basically involve throwing ridiculous amounts of hardware at a problem. I still want to spend some time doing some deep research into reinforcement learning to try and find ways to make it work better on smaller amounts of resources and on kind of more practical problems. Not many people need to win Dota or Go. Unsupervised learning, definitely, kind of. I don't really believe that there's such a thing as unsupervised learning, but I do believe very much in what Jan LeCun calls self-supervised learning, which is coming up with a supervised learning model which doesn't require explicit labels. And so, for example, ULM fit is entirely based on something called a language model. A language model is just a model which predicts the next word in a piece of text. So you don't need any labels, you just need some text, and you can build a model that tries to predict the next word after every sequence. So that's a self-supervised model because it uses the input data itself to generate labels. So I'm very keen to continue to provide richer and richer and more varied self-supervised learning support, because that allows you to do transfer learning even in situations where you may not have explicit labels.
The idea of self-supervised learning, as you described it, is related to another recurring theme that comes up from time to time on the podcast, and that is incorporating model-based approaches into deep learning models like physics-based approaches or other, depending on the domain. Yeah. Is that something that you are interested in? You're seeing, and do you see it? How do you see it working with the library?
Oh, yeah. So very much so. It's something I'm really enthusiastic about. I mean, a great example of a model-based approach is the convolutional neural network. So if you start out with the observation that your data is autocorrelated along some dimensions. So, for example, in an image, one pixel tends to be similar to the pixel above it and to the left of it and to the right of it and below it. So you've got two-dimensional autocorrelation. And so a convolution is an operation explicitly architected to allow it to be easier to identify those kind of autocorrelated patterns. So like a CNN is a great example of a kind of model-based or model-inspired architecture. Then there's, more recently, there's been a lot of, maybe not a lot, quite a few good examples of places where domain experts have come up with kind of tweaks to an architecture which allow it to, more easily represent the kinds of things that are most common in that domain. So, for example, there was a couple of papers, one of which was by Sander Dieleman, talking about group convolutions, which is basically saying, hey, if you're doing something like pathology images or satellite images, which are rotation invariant, here is an architecture that is explicitly designed so that rotation invariance is built into the very architecture. I've seen similar things in models for physics, where the kind of basic invariances or constraints of what would be required in those physics models are built into the architecture. So with Fast.ai, we've tried to make that kind of thing pretty easy to add because there's this idea of a custom head. You can very easily create a custom head for your architecture, which might contain some of those ideas. Or you can create a custom module, a custom nn.module, a Pytorch model, and pass that directly to a Fast.ai learner. And we've kind of provided lots of hooks for you to make it easy to add all the additional Fast.ai features into your model. So yeah, I think we've tried to support what we can there, and maybe people who are interested in specific domains that already have some kind of model-inspired architectures, hopefully we'll be able to start contributing some of their approaches.
Maybe to start to wrap things up, I hear you're writing a book on machine learning. What's that going to cover?
Okay, so we've got two books coming up. One is a book with Professor Terence Parr about machine learning. The first few chapters are available in an early draft form online, and it's basically inspired by the course. So Terence Parr, some of your listeners may recognize the name. He's a pretty famous computer scientist who built the Antler parser generator, which I guess is kind of the most widely used parser generator around. And he spent decades becoming, I'd say, the world's leading expert, or certainly one of them, in parser generators. And he's now turning his attention to machine learning. And he He's a colleague here at the University of San Francisco. He actually sat in on my machine learning course when I taught it and said, like, oh, I like that so much, I think we should write a book based on it. So, yeah, so we're doing that. And everything Terence does, he does exceptionally deeply and exceptionally well. So if you check out some of the early material, you will see there's a lot of beautiful visualizations and really nice descriptions. The second book is with Sylvain Guger. Sylvain, some of your listeners may recognize as being an exceptional student from an earlier course who repeatedly wrote brilliant material that I featured in the course. And since then, he's gone on to do some really cool research around transfer learning. And AWS were kind enough to actually sponsor him as the first Fast.ai scholar in residence. So he's been working full-time with us for most of this year, and he's going to help me write a book about the Fast.ai deep learning library and learning deep learning using the Fast.ai top-down approach. So that one's going to be coming out, published by O'Reilly sometime in 2019.
Oh, awesome. Awesome. Related to your own evolution in this space and what you've seen from Sylvain, I'm sure you've been asked, like, for folks that are interested in this field, don't want to get a PhD, but want to contribute to research. Do you have a kind of a path that you point folks down?
Yeah. So Sylvain would be a great example of that. His background is pure math. So minimal computer science. He's actually visiting us in San Francisco this week, so I've just been chatting to him about this. And he was telling me, he's been doing deep learning for less than a year, and he thinks his story of kind of going from a pure math, minimal computer science background to contributing to the Fast.ai library and doing, well-regarded research is kind of a good example of how people it doesn't have to take a long time. You don't have to have some kind of formal background. I think, all it needs is tenacity. I think it requires strong coding chops. And so, Sylvain's been working very hard to become a better coder. Because then you can, run lots of experiments. Every time you come up with an idea, you can try it out. And then just, start writing simple little blog posts. Like just pick something that you've seen come out where somebody maybe give you a simple example. ULMFit came out showing good results on English classification. So if you speak French, why not try it on French classification? And that's a simple piece of research, and you can write a blog post, or you could write a PDF or put it on archive showing your results on French. And then maybe you could say, well, now that I've done French classification, let's also try sequence to sequence, or let's try sequence labeling, little extensions. And you'll be pretty surprised that as you kind of keep publishing little extensions to something that you like, pretty quickly you'll find that you've somehow become more of an expert on that particular area than anybody else, and people start coming to you for advice, and you can start suddenly realizing, when Jeremy and Sebastian did that paper, they never tried this other technique. So maybe it'd be like, they didn't try using a transformer model. Maybe I should try a transformer model instead of an LSTM. Let's try that. And so, just keep digging, keep trying things. I'd say try to be as practical and useful as possible. Don't get too lost in the math. And then, if you start coming up with some things that start showing good results, you can reach out to other people who have been doing work in that field and say, here's my results, here's my code. What do you think? And if they think it's good, maybe you can start doing some collaborative research with other people, which is exactly how Sebastian and I ended up doing some work together. And nowadays, Leslie Smith and I are, talking about collaborating. It's all about doing useful work in a field and getting to know some of the other folks that are doing that kind of work too.
Leslie, we know from the work on cyclical learning rates that was featured in the library, right?
Yeah, and the learning rate finder, and more recently the one cycle schedule that's going to be kind of the main featured training method in Fast.ai version 1. And perhaps most importantly, the superconvergence phenomenon that we're finding we can train things 5 to 10 times faster than we were before he discovered that.
Well, that sounds like another conversation, maybe one that I'll need to have with him.
Yeah.
But for now, Jeremy, thank you so much once again for taking the time to chat with me. It was really great having you on the show.
My pleasure. And I hope folks, if people are interested in the Fast.ai library, if you just go to docs.fast.ai, you'll find all the information to get started there, and come to our forums and tell us how you go.
Fantastic. Thanks so much.
Thanks, Sam. Bye-bye.
All right, everyone, that's our show for today. For more information on Jeremy or any of the topics covered in this show, visit twimlai.com/talk/186. You'll find there a link to the Fast.ai library and the new Fast.ai courses as well. To join our community of machine learning enthusiasts, including our study groups for the Fast.ai courses, visit twimlai.com/meetup. If you're a fan of the podcast and you haven't already done so, or you're a new listener and you like what you hear, head to your Apple or Google podcast app and leave us a 5-star rating and review. Your reviews help inspire us to create more and better content, and they help new listeners find the show. As always, thanks so much for listening, and catch you next time.